Hey everybody, my name is Taylor Compton. I'm the warehouse and service manager here. I started in the fall of 2013, and repairs has been a big part of my responsibility since I've started. So what we're looking at is our 424. This is the poly version of the pump. This is the 39-inch. This is one of our bread and butter products. Why we chose it first, it's our sealless pump. And so today what we're going to do is we're going to take this pump down to complete individual components. You'll see every part and why it might need to be replaced and what might go wrong with it. And also cover the typical repair as well as parts that we typically don't replace or repair due to economical reasons. So the first thing we're going to do is we're going to look at the tools that we use for this. You can see here, one of the first items is a clamp. Okay, this goes into any standard vise, and it holds our pump tubes in a manner that prevents it from getting damaged. It comes in 3 different sizes. This is a 43mm clamp. It also can come in 50 and 54mm to hit our high viscosity pumps. Next we have a T-piece tool. This is a little flat bladed end. It is used to hold our coupling while we are removing the impeller and keeps it still. If you don't have one of those, this is a flux clip, comes with every pump. It is a star shape. If you could see that, I'm trying to get into a position where you can really see it well. That also will hold the coupling. On the other end of the shaft, while we're removing the coupling, is this tool, which is the impeller tool. You see there's 3 little arms there that grab the 3 blades on our radial impeller. Kind of looks like a little torture device. Next we have 2 individual presses. This one is a press that has a flat seal or flat face to it. It's used on this while removing the lip seals. We're going to tap them down and kind of get them broken free. But also there's a hole in the center, and that's used with 430s. That's for mechanical seal replacements. It's for the spring. And then we have our second press here, which has a little shaft on it. That is for reinserting the lip seals. So the little lip seal sits right there on top on the shaft, and that holds it steady while we press it in. Next, also used for lip seal replacement, we have this homebrew tool. It's nothing fancy. It's a pair of vice grips, and if you see there towards the end is a nail that we kind of put a hook in. It's a heavy galvanized steel nail, so it won't bend or break. We use that to pry the lip seals out of the inner tube, and it's a flat nose so it doesn't scratch or damage the inside. If you need one of these, you could let us know. You can either make it yourself, or we can make you the nail. And, you know, most people have a pair of lockjaws. We also have, for this repair, a pair of circlip pliers. Those are hooked on the end, and they fit into holes on our circlip. You got to make sure you have the ones that when you squeeze the handle, you expand. Some of them are the opposite. This is for the circlip. Also, you're going to need a hammer, which you can see here. Any hammer works, of course. And we've got 2 shafted tools with a little handle at the end. And these are for the spiral replacement. So if you can see here, this tool has a hook at the end of it, and that is for removing the spiral. We're going to latch on and pull it out. And this second one here is a little longer of a shaft, and it has a retractable hook. So you can kind of see it there, and now it's much more visible. This is for reinserting the spiral. Also, this has a depth on it. So if we're looking here, you can see the little lines and grooves on it. Those are for finding your depth. And we can go back to a regular view. I'll show you how that works. So there's notches here, 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 and here. So So when we find the spiral, we line up on the pump where the center would be. We find the notch that's at the end of the inner tube, and that's the depth. So let's get into it, shall we? I've got my normal vise here. Okay, got some positions. Another thing that's really handy while we're here is there is grease on certain components in here. So shop rags, really handy. And also before you do an actual repair, you'll want to put on gloves. This is a new pump, never touched product, so I am not going to do that. But of course you always want to make sure it's clean and any hazardous chemicals are out and off the pump. So anyone who is familiar with our pumps knows that we have a top pull-out design, but on the F424, the first thing we have to do is remove our foot piece and our impeller. And so those are the first two things we're going to look at in a repair, so I'm just going to go in order. So the foot piece is a reverse thread design. So right is loose and left is tight. Okay. So as we get here, you can see there's 4 tabs on our foot piece. You want to make sure those are intact. What that does is it eliminates a Venturi effect, so the pump doesn't move any air inside. And you also want to check, of course, the housing of the foot piece, make sure it's not cracked or damaged, and then the threads inside, making sure that they are not cross-threaded or damaged in any way. This happens because when you drop the pump and motor combo into a drum of product, this is taking the brunt of the product, the force. So we'll see a lot of times this gets cracked or split, falls off completely if they're just dropping it in. It is pretty tough, so it's not like very easy to do that to, but it does happen from time to time. Also, you can damage it if you pump a screw or bolt, things like that, of how the vanes typically break off, or the little tabs, stuff like that. So, of course, we have a new pump clip. We need to replace that. So now we're going to remove the impeller. So I hold our coupling with our T-piece. And this is a normal thread, so no need to remember anything special about it. Okay. So what we're going to do is we're going to look at the impeller. You can see all 3 blades there. Now this is ETFE. It's a really tough impeller. But again, if you pump something metal, bolts, screws, really big sticks in outside containers, you'll nick these or damage them. I've never actually seen one where the blades have completely broken off, but I have had to replace these. There's also a bolt in there which sometimes loosens up when you jar it very strongly. So now that we have removed our foot piece and impeller, we've got our top pull-out design. What we're going to do is we're going to set this aside for right now, and we're going to look at the rest of the inner tube. So we've got our bearing support, or our lower drive shaft bearing support. And again, I'm also going to set this aside because we're going to look at this later when I pull the shaft out. And what we have left is just the bare outer tube, union nut, and circlip. So what we look at here is we look at the top of the pump. We look at our discharge threads, right? Make sure those aren't cross-threaded. Sometimes people will put metal union nuts on this and will cross-thread it accidentally. We want to look at the top part here, make sure that's not broken or cracked. It happens occasionally if someone is over-tightening this to the motor. They use a tool like a strap wrench or something along those lines to crank down on this. That does not need to happen because this is plastic, but they do that. And they'll either break the union nut down here at the bottom, or they'll actually break the outer tube, which is a much more expensive piece because there is a groove there that you can see that silver piece sitting in. That's what locks down the union nut. Also, we look at the bottom and just check these threads down here where the lower bearing goes to make sure those are in good shape. So if you do need to replace the union nut, like it took a tumble and fell, cracked, split, made sharp edges, we take our pliers here We pull the circlip off, also making sure that it's not rusted or corroded or stretched out. And then we just have our union nut, pretty simple. And then again, you can see really well that groove where that circlip sits, make sure that it's not damaged. That's everything for the outer tube. Now we look at our inner tube again, and we want to pull the shaft out next. So we have a hard concrete floor back here in the warehouse, so we just gently tap, and out comes the drive shaft and coupling cage complete. We're going to set this aside and look at that later again. So what we have is the coupling still attached to the drive shaft. I'm going to use the drive shaft to get it close up. And this is the normal thing that goes bad, that really people get, or that they notice, is these bearings down here get corroded, and they lock up, or they dry up, or they rupture altogether because it's been run so long after it's locked up. And so those are our normal repair. I'm going to show you how to avoid that, because that's a more costly repair than a standard, than what we could do to avoid that. We also look here at our coupling star, which is that red piece in there, make sure it's in good shape, and our coupling cage, we want to make sure all 4 tabs are there and in good shape. So if you need to remove that, we're going to lock the drive shaft here in my vise. And our little coupling tool, make sure it's nice and tight so that we don't scar up the drive shaft, and it just threads off like normal. You can also break the coupling down in pieces. The coupling cage is a single piece, the bearings are a single piece, and the star is a single piece, as well as the spacer. All available for purchase. So now we're going to look at the drive shaft. We look here in this section at the top where the coupling was. We look for thinning of the drive shaft, or where the lower bushings are. We look here in the middle where the spiral sits for the same thing, thinning of the shaft, burns, anything like that. And we look down here at the bottom where the lower bushing was for similar damage. We also want to eyeball it and check for straightness. You can also roll it along a flat surface to make sure that it is still perfectly straight. At 10,000 RPMs, puts a lot of stress on it if it's bent. So now we move on to our actual inner tube. And this is just a poly piece, it's a spiral, 2 lip seals that sit here, and an O-ring right there. So the first thing we're going to do is we're going to check our O-ring. You can see it sitting here near the top of the inner tube, making sure that it is still stretchy, not damaged at all, dry, rotted, anything like that. And then we're going to look at the bearings inside. We also check this piece in general, making sure that it's not the weld isn't broken, it's not cracked, it's not sliding off or detached. So that's another thing that just happens from chemical and age. So now we're going to pull out our lip seals. Maybe take our flat press, our flat punch, line it up on the seal, and a gentle tap. We do that just so that we break it free and it's easier to pry out. Also, a bearing puller will work with this if you have a small shafted one. And here is the first lip seal. Again, we have 2. So we're going to do the same process again. That one always sounds a little more because that lip seal is bottomed out. So it's a little louder than the fit. And there's the second lip seal. And we're going to take a look at these. You can see them there. These are new ones, of course. There's a couple things we look at them. One is inside this area here is a metal spring that goes all the way around. It's a compression spring. And we want to check to make sure that the diameter is correct by taking our drive shaft and we fish the lip seals onto it to make sure that they're making a good seal and good contact all the way around. That's only needed if it's really obvious, and sometimes we just replace these anyway. We usually do because these are what protect the bearing and keeps the bearing and the coupling cage running longer. So the next thing that we do is we're going to check our lower bearing, which is what we took off of the inner tube. And we do the same test that we just did where we thread the shaft through it. Okay? We make sure it's making good contact all the way around, not wobbly, and it's supportive. Okay, so the last thing we want to do, we don't normally have to do this. If you look at the drag shaft and you see it's not burned in the middle, is we pull out the spiral and we might have to replace that. I'm going to go ahead and show you what that looks like. So, I'm going to flip it down here. Okay. So we take our tool with a hook. This is the shorter of the two. And we thread it along that spiral a little bit. Sometimes it slips off. It's okay. We pull, and there it is. I'll go ahead and pull it the rest of the way out. So there's our spiral. You want to check this again with our drive shaft. Sometimes it's very obvious why it needs to be replaced. Sometimes it's not so obvious. It should fit real loose. You can see it rotate there in the camera. Because once you put it in the inner tube, it compresses and it's going to be a little more snug. This gets bad sometimes if you have a product that crystallizes, it doesn't fully drain out of the pump. It will add some thickness to the spiral, which compresses the shaft a little more. Also, if you have a customer who's ever taken these apart, when you're putting these back in, sometimes they'll catch the top of the spiral and compress it extra, and they'll, over time, add resistance because obviously if this is not spiraled out, it's thicker and is going to have a smaller opening in the middle. So if you get down to this point and you've identified the parts you need to replace, which are typically the lower bearing, the bearings on the coupling cage, and the lip seals, that's our typical repair, then we have to put it back together. So we're going to take our spiral insertion tool. We're going to feed the spiral on it. And what you're about to see is how we fish this in here. So we have our hook, we have our spiral, okay? There is a hole in the spiral, if I could get a good picture of it, right there. So that retractable hook fits into that hole, as I think you can now see. So that holds the spiral in place. What we're going to do is we're going to say it needs to go right here, and we find the notch that lines up with that location. So I'm going to mark it with my thumb as I push the new spiral back inside the inner tube. Well, came off. Out of all the rehearsals, this did not happen. All right, there we go. Now it's going. All right, so we marked it with our thumb, and we push it back in. And shop racks. We'll wipe this down because it's a little greasy, taking it apart. We just want to clean it up. We want everything to look as new as possible when we send it back out. So now we got to put the lip seals back in. Tighten that back up. We're going to put a little grease on them if you need to. And we press in one. That goes all the way down to the bottom until it bottoms out. The second one, we only want, there's a small lip inside the inner tube of metal which I think you can see there, we want the second lip seal just below that lip, almost flush with the surface. So we're going to press it in just a little bit until we think we're there. And now I think you can see the difference. Maybe there. You see the lip seal is just below that metal ring. Okay, after that, we can put the coupling cage back on the drive shaft. If this is damaged here or worn here and here, you can reverse it, which I'm going to show you. That saves our customer a lot of money because this drive shaft is half full AC and it is our single most expensive part on the 424. The fact that it's reversible. Okay. We pass it back in. Okay. Smack it down. Another thing that's good about our pump is the coupling sits flush with the top of the inner tube, so it cannot get caught and broken off like some of our competitors do. Now, we take our inner tube and our outer tube, and we can pass this back together. Then our new lower bushing will go back on the bottom. It only goes one way, and I'll show you how that works. We have an open end there and a flat end here. So the open end catches the bottom of the inner tube, keeping it still while in operation. Again, remember, left is tight on this one. Okay. I'm going to put it back in our clamp. Sorry about the noise there. Back with the impeller. Standard threads on that. And now we can tighten everything up. And then foot piece. And finally, we put our union net back on with the new circlip. And you now have a fully functioning pump. Okay, looks like we got some questions back there. Can we buy only part of the coupling cage? Yes, we can. So that the coupling cage is completely modular in a sense that every component is individual, from the coupling star, the coupling cage, the spacer, and the two bearings. So each part is sold separately, but also it can be sold as a single unit already assembled. The difference between the PP and the PVDF pump and the stainless steel EX, there is only one difference. The polypropylene and the PVDF are identical to what I just showed you. However, the stainless steel has an explosion zone here at the top, which looks like a little window. And as a result of the addition of that explosion zone, it only has one bearing on the coupling and one lip seal, and a brass bushing below that lip seal. So that is the only difference between the poly pump, PVDF, and stainless. Can we buy the tools? Yes, the tools are available. We, again, sell them either individually, or we can sell them as a kit, which the FLU number for the kit will be available shortly. Any repairs that we shouldn't attempt here at Flux or on the customer site? There are a couple repairs that we don't do, especially with on this pump. That is only for economical reasons. The entire pump is fully repairable, no matter what stage you're in. However, because our typical repair includes the lower bearing, the coupling cage complete usually is what we do, and just do everything, and the lip seals, things like the drive shaft, which is again the most expensive component, the inner tube, and the outer tube. When you add that cost together with the rest of the repair, typically, economically, it's not logical. You're well over 50% of the cost of a new pump, and most customers will just go ahead and make the replacement. If you only need one of those pieces, and we have done that, then yes, it makes sense to replace those, but not in conjunction with other parts.